Welcome to interpreting the p-value. Again, we're focusing on one-way ANOVA. So we're going to continue on with the same video the same example I've been using for all the Model 26 videos. So a university wished to compare the study skills levels of the different years on campus. A researcher randomly selected 10 students entering their first year, 10 students entering their second year, and 10 students entering their third year. The researcher had all of the selected students take a study skills test, which was scored out of 100. The researcher then compared performance by year. The data is recorded below. Can we conclude at the 5% significance level that not all 3 years have the same average performance? So recall some things that we've seen in the previous Module 26 videos. We have our hypotheses. The null hypothesis was essentially that first year, second year, and third year students at the university all average the same score on the study skills test. And the alternative hypothesis was essentially that they do not all average the same score. So the years do not all average the same score. Then in the previous video, we had seen the p-value. So there was some work in the background,
two pieces.
but we found a p-value of about 0.306. So again, putting this in context, what the p-value is saying is there is a 30.6% chance that
one for each hand.
The 3 random samples of first year, second year, and third year students each of 10 students would have sample means as different as ours if first year, second year, and third year students all average the same score on the study skills test. So if first year, second year, and third year students all average the same score on the study skills
See, one side is brown, one
test.
side has colors.
So some key components of this. There's a 30.6% chance, that's just the p-value in percent form.
Yeah. Uh-huh. Well, you're trying to make a wide enough space for yourself now. You're on your way over to mommy.
So we have our p-value in percent form. Then from there, the 3 random samples of first year, second year, and third year students, each of 10 students. That's essentially how our samples were, or what type of sample were found. So this is essentially a description of the sample description of the samples that we've gotten, right? Or how we got our samples. Then we have would have means, sample means as different as ours. That's sample, get sample results as extreme as our results. And then our big if first year, second year, and third year students all average the same score on the study skills test, this is our null hypothesis. So if the null hypothesis were true. So hypothesis tests in general, we always are operating under the assumption the null hypothesis is true. So essentially, this is the chance, if the null hypothesis is correct, this is the likelihood of getting samples as extreme as ours, which is always what we are doing with a p-value. So from here, we have our conclusions. So our p-value here was not surprising, or our p-value did not indicate that our samples were surprising. So with a p-value of 30.6% chance, right? Then this means that our samples were not surprising. So our samples were not surprising. If the null hypothesis were true. And so that means that we don't have enough evidence against the null hypothesis. So we don't have enough evidence against the null hypothesis, or in other words, for the alternative hypothesis. So our final concluding sentence would be, we don't have enough evidence to conclude at the 5% significance level that first year, second year, and third year students do not all average the same. first year, second year, and third year students at the university. Do not average the same score on the study skills test. So again, the key feature here is we do not have enough evidence. So we've basically proven nothing. We haven't shown that they're the same. We just do not have enough evidence to say confidently that they are different. So that is one way ANOVA split over quite a few videos.